This is SpaceTime, Series 22, Episode 88. Coming up on SpaceTime. The Wolfe Creek Crater younger than thought. Scientists complete the first global map of Titan. And the discovery of exoplanets unlike anything in our solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that Wolfe Creek Crater, one of the world's youngest meteorite impact craters, is far younger than previously thought. The crater at the edge of the Great Sandy Desert in northern Western Australia, just near the Northern Territory border, was thought to be around 300,000 years old. But a new report in the journal Meteoritics and Planetary Science suggests it may only be 120,000 years old, less than half the previously estimated age. With a diameter of 892 metres and a depth of 60 metres, Wolfe Creek Crater is the second largest impact structure on Earth from which meteorite fragments have actually been recovered. The planet's largest is the Barringer meteor crater in Arizona, which is around 1,186 metres wide and 170 metres deep. It's thought the Wolfe Creek Crater was likely formed by a meteor about 15 metres in diameter, weighing around 14,000 tonnes. However, the age of the crater has always been poorly understood, with unpublished data suggesting an impact occurred around 300,000 years ago. However, this new study, using two geochronological dating techniques, have come up with a likely meteor impact age of just 120,000 years. The study's lead author, Dr. Tim Burrows from the University of Portsmouth, says the crater is located in a fortuitous situation where scientists could use two different dating techniques to determine its age. First, the researchers collected samples from around the crater's rim and applied exposure dating, which estimates the length of time a rock's been exposed on the Earth's surface to cosmic radiation. They were also able to determine the age through optically stimulated luminescence, a dating technique used to measure how long ago sediment was last exposed to sunlight on sand buried after the impact. Burrows says the impact of the meteorite tilted and overturned the rock, exposing rock that was previously shielded from cosmic radiation. The newly formed crater also deflected the local wind field, thereby creating a new set of sand dunes. Fortuitously, the results from the two different dating techniques mutually supported each other within the same age range. Researchers were also able to produce a new topographical survey of the crater using aerial images. That provided a three-dimensional model that was used to create a digital elevation model of the crater. The authors found the crater has a maximum width of 946 metres in a northeast-southwesterly direction, reflecting the direction of the impact. Averaged out, the crater's diameter is 892 metres. They also predicted an overall crater depth of 178 metres, of which around 120 metres is filled in with sediment, mostly sand blown in from the surrounding desert. All this means that Wolfe Creek Crater is now one of 7 sets of impact craters in Australia, dating back to within the last 120,000 years. Now, from this, researchers could easily calculate just how often these crater-producing events occur. Burrows says although the rate is only one large meteor hitting Australia every 17,000 years, it isn't quite that simple. You see, the craters are only found in arid parts of Australia. Elsewhere, the craters are being destroyed by geomorphic activity like river migration or slope processes in mountains. But since Australia does have an excellent preservation record with dated craters within its arid zone, scientists can use this to estimate the rate for the whole Earth. Taking into account that arid Australia really only covers about 1% of the planet's surface, the rate increases to one of these asteroids hitting the Earth roughly every 180 years or so. And there have been two big impacts which hit the atmosphere in the last century, Tunguska in 1908 and Chelyabinsk in 2013. The authors estimate the number of large objects hitting the atmosphere is probably about 20 times this number. That's because stony meteorites are far more common than iron ones, but not many of the stony ones survive the fiery journey through the atmosphere or effectively make craters. Still, Burrows' results provide a better idea of just how frequently these events occur. Now, using the same geochronological dating techniques, the same researchers were also able to recalculate the true age of Meteor Crater in Arizona. They found it's more likely to be 61,000 years old, some 10,000 years older than previously thought. You're listening to SpaceTime. Still to come, scientists complete the first global map of Titan, and astronauts successfully complete the first 2 of 4 spacewalks to service the Alpha Magnetic Spectrometer, a vital instrument aboard the International Space Station studying antimatter, cosmic rays, and mysterious dark matter. All that and much more still to come on SpaceTime. Scientists have completed the first global geology map of Saturn's largest moon, Titan. The new map reveals a dynamic world of dunes, rivers, lakes, plains, craters, and other terrains. Titan is the only planetary body in our solar system other than Earth known to have stable liquid on its surface. But instead of liquid water raining down from clouds and streaming into lakes and seas as on Earth, on Titan it rains liquid methane and ethane, hydrocarbons, which usually only exist as gases on Earth, but behave as liquids in Titan's frigid climate, which is so cold water's frozen solid, forming much of this distant world's bedrock. The study's lead author, Rosalie Lopez from NASA's Jet Propulsion Laboratory in Pasadena, California, says Titan has an active methane-based hydrological cycle that has shaped a complex geologic landscape, making its surface one of the most geologically diverse in the solar system. Despite the different materials, temperatures, and gravity fields between Earth and Titan, many surface features are similar between the two worlds and can be interpreted as being products of the same geological processes. The new map of Titan shows different geological terrains have a clear distribution with latitude globally, with some terrains covering far more area than others. The findings, which include the relative age of Titan's geological terrains, have been published in the journal Nature Astronomy. The authors used data from NASA's Cassini spacecraft to develop their map. Cassini, which operated between 2004 and 2017, undertook more than 120 flybys of the Mercury-sized moon. The Cassini mission revealed that Titan is a geologically active world, where hydrocarbons like methane and ethane take the role that water has on Earth. These hydrocarbons rain down onto the surface, flowing in streams and rivers, accumulating in lakes and seas, and eventually evaporating back into the atmosphere. This is SpaceTime, still to come. The discovery of planets in nearby space unlike anything in our solar system. And later in the science report, spotting fake news is difficult enough these days, but what about spotting fake or junk science news? All that and more still to come on SpaceTime. Astronauts aboard the International Space Station have carried out the first 2 of 4 planned spacewalks to service the Alpha Magnetic Spectrometer, a vital instrument which is studying antimatter, cosmic rays, and dark matter, some of the biggest issues in astronomy and physics today. Launched aboard one of the very last space shuttle flights back in 2011, the Alpha Magnetic Spectrometer, or AMS-02, was originally designed for a 3-year mission and was never intended to be maintained in orbit. But after 3 very, very successful years of delivering groundbreaking science, the decision was taken to extend its lifetime. Scientists and engineers then began the monumental 4-year task of working out just how to develop and undertake a servicing mission to keep the AMS-02 going. That included developing special procedures and an array of more than 20 new tools to undertake the complicated operation. The first extravehicular activity, or EVA, that's NASA speak for spacewalk, took 6 hours and 39 minutes. The astronauts' first task was removing the debris shield that covers the AMS instrument. Mission managers were unsure if this would even be possible after 8 years of exposure to space, but the astronauts used their specially designed new tools to successfully remove the protective shield and cast it away, just another piece to add to the growing list of space junk orbiting the Earth. The second tricky task was clearing a way into the service channel, where the instrument's 8 stainless steel cooling pipes are housed. The astronauts had to unscrew bridges over the cooling tubes and then connect a new data cable. These tubes will be cut and spliced together over future spacewalks. They also installed 3 new handrails in the vicinity of the AMS in order to prepare for the second spacewalk and removed zip ties on the AMS's vertical support strut. The second EVA, a few days later, included cutting and labeling the 8 stainless steel pipes attached to the AMS's current cooling system. In addition to the overall complexity of the instrument, astronauts had never before cut and reconnected fluid lines like those that are part of the AMS thermal control system during a spacewalk. The 6-hour, 33-minute second EVA also prepared a power cable and installed a mechanical attachment device in advance of installing the new cooling system. All this work for these first 2 EVAs clears the way for the third spacewalk next month. At this stage slated for December the 2nd, which will bypass the old thermal cooling system by attaching a new one off the side of the AMS and then reconnecting all 8 pipes before conducting cooling system leak checks on a 4th spacewalk. This report from ESA TV.
Our universe is a giant cosmic puzzle because most of it appears to be missing. The matter that forms the stars in our galaxy and the planets in our solar system only accounts for around 5% of the universe. To discover the elusive particles that make up this missing dark matter, scientists have been using an instrument called the AMS attached to the outside of the International Space Station.
The detector is a magnetic spectrometer. It's a very precise magnetic spectrometer, normally used in accelerators like CERN. And this is the first time anyone has ever put a very precise, long-duration magnetic spectrometer in space.
The Alpha Magnetic Spectrometer, or AMS, is a particle detector that took 16 countries nearly 20 years to develop. Assembled at CERN, tested at ESA's ESTEC facility, its principal investigator is a Nobel Prize-winning physicist. The AMS looks for dark matter, antimatter, and measures cosmic rays, high-energy particles that travel through space at close to the speed of light.
Inside AMS, there are 7 layers of different detectors to identify all the cosmic ray particles, such as electrons, positrons, protons, antiprotons, and elements across the periodic table.
The AMS has been searching for the unknown since it was installed on the space station in 2011, the first instrument of its kind to work in space. Since then, it has collected over 145 billion cosmic ray events that range from low to extremely high energy levels. Some of this cosmic radiation is dangerous to human health, so we need to improve our knowledge in order to eventually live on the Moon and Mars. Data from the AMS is sent via NASA for analysis at CERN's Payload Operations Control Center. Excitingly, the results are contradicting existing theoretical models of subatomic physics, and according to Professor Ting, are beginning to revolutionize our understanding of cosmic rays. But the AMS cooling system was originally designed for 3 years, and so ESA's Luca Palmitano performed several challenging spacewalks to replace it. He arrived on the space station as part of the Beyond mission in July and knows that scientists on Earth are depending on him.
What is important is the person is very calm and knows the instrumentation and very careful, because often one mistake is your last mistake. And so I think we're really very happy that Luca is there.
The repair of the space station's largest instrument will ensure that the AMS can continue to provide more data and more groundbreaking science. It has already produced the most precise measurements yet of high-energy cosmic rays and the first insights into potential antimatter and dark matter. Scientists now want to make sure that what was observed resulted from collisions of the enigmatic dark matter.
And that report by ESA TV included AMS Principal Investigator Professor Samuel Ting from CERN, the European Organisation for Nuclear Research, and MIT, the Massachusetts Institute of Technology. And this is SpaceTime. Still to come, warm water fish species migrating into areas formerly inhabited by cold water species. It's all due to climate change. And scientists develop virtual skin. All that and more still to come on SpaceTime. NASA's newest planet-hunting spacecraft, TESS, has discovered a pair of mini Neptune-sized exoplanets, a type of planet not found in our solar system, orbiting a nearby star. The pair were part of a trio of planets found by TESS, the Transiting Exoplanet Survey satellite, orbiting a star some 73 light-years away, which, when you think about it, is really just down the road in astronomical terms. A report in the journal Nature Astronomy claims the 3 newly found exoplanets include 2 gas planets roughly twice the size of the Earth, and a terrestrial world only slightly smaller than Earth. More interestingly, the terrestrial planet is orbiting in its host star's habitable zone, the distance from a star where temperatures are warm enough for liquid water to exist on a planet's surface. The study's lead author, Associate Professor Stephen Kane from the University of California, Riverside, says the new star system called TESS Object of Interest, or TOI 270, is exactly what the satellite was designed to find. Kane says very few planets like these have been detected in the habitable zone around a star, and very few around a quiet star, making this a rare discovery. A quiet star is one which experiences very few stellar flares, thereby allowing scientists to observe it and its orbiting planets more easily. And that's important because in our solar system there are really only two types of planets. They're either small rocky terrestrial worlds like Mercury, Venus, Earth or Mars, or they're much larger gaseous worlds like Jupiter, Saturn, Uranus and Neptune. These are worlds dominated by gases, or in the case of the ice giants Uranus and Neptune, by gases and ice. Our solar system's unusual in that it contains no super-Earths, no planets half the size of Neptune, although these size planets are very common around other stars. And being so relatively close, just 73 light-years away, and orbiting around a fairly quiet star, means this newly discovered system will allow scientists to study this missing link between rocky Earth-like planets and gas-dominated mini-Neptunes, because all of these types of planets were formed in the same system. Follow-up observations of the system have now been planned for 2021, when NASA's new James Webb Space Telescope comes online. It'll also be able to measure the composition of the TOI 270 planet's atmospheres for hydrogen, oxygen and carbon monoxide. Kane says these kinds of observations will help determine whether a planet has ever had a liquid water ocean and whether any of the planets have conditions suitable for life as we know it. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Some new exoplanets that have been discovered by TESS.
Yeah, TESS, the planet-finding satellite that in many ways is a successor to the Kepler spacecraft that was so successful in finding planets orbiting other stars by the dimming of the light of the star as the planet crossed in front of it. So TESS is an acronym for Transiting Exoplanet Survey Satellite. It's a NASA spacecraft and it's already doing its thing in terms of discoveries of new planetary systems. I think, if I remember rightly, one of the distinguishing features of TESS is that it will survey a very, very wide area of sky, unlike Kepler, which looked at really quite a limited area of sky. So TESS has I think it's got the wherewithal to look at the whole sky. And by doing that, you can build up statistics in perhaps a more sensible way than if you're just looking at one tiny patch of the sky where, you don't have the benefit of saying, well, this is a global phenomenon. So one of TESS's discoveries, which is called TOI 270, and TOI stands for TESS Object of Interest.
Oh,
which is quite a nice acronym, really.
Basic, but functional.
Yeah, functional. That's right. It tells it like it is. TOB would be a TESS Object of Boredom, which would be the opposite, really. But this isn't a TOB; it's a toy. So this is the 270th of these TESS Objects of Interest, and it's already got scientists excited. There is a paper in a very recent issue of Nature Astronomy which talks about this system of not just one, but actually 3 planets that have been discovered, with the possibility that this solar system might have more planets as well. So you're quite right, it's relatively nearby, 73 light years away as the crow flies. But what we are seeing in this system is a rocky planet and 2 planets which are a bit smaller than Neptune, so that they're called sub-Neptunes, super-Earths.
I don't like that. I don't know why, but it really narks me. It's like when they talk about a super virus. It just, it's a virus or it's not.
Yes, I'm not keen on super as a descriptor. Yes, super Earth. Anyway, it means it's bigger than Earth. I suppose if it's much bigger than Earth, it's a super duper Earth, but this is only a super Earth. So it's all about, what's really interesting is how these planets are formed and how they come to be in their present sort of circumstances within their respective solar systems. And the reason why I mentioned that is that these planets, they form what's called a resonant chain. A resonant chain is where you've got, how can I put this? The best way to put it is that if you look at the ratio of their orbits, either in the time it takes to go around their parent star, or the semi-major axis is the technical term for the distance to the parent star on average. If you look at that and look at it for the whole family of planets, then when you look at their ratios, they're in integral numbers. For the inner pair, it's a 3-to-5 resonance. For the outer pair, it is a 2-to-1 resonance, but still these resonances occur. We've got a similar thing in the solar system with Neptune and Pluto. I think it's a 2-to-3 resonance there. I can't remember. But that's telling you that the gravitational pull of Neptune has had a significant effect on the dwarf planet Pluto and pulled it into this resonance. So that's, something that exists with TOI 270, this resonant chain, and it's possible that there might be further one out that would also be in resonance at another integral ratio. It means as well, from time to time, what happens to these planets is that they line up perfectly, because as the resonances go through, you're going to get a situation where they're all in a straight line. That's not something that it's displayed yet, but that would happen. The furthest planet also seems to be in what you might call the Goldilocks zone of the parent star, where liquid water could exist. But it's thought that there is a very thick atmosphere, and it may even be that it doesn't have a solid surface at all. So it's really only the top of that planet's atmosphere that has the magic Goldilocks temperature. That's interesting, and it also tells you something about the star. So that's the furthest out of these planets that's in the Goldilocks zone. When you think of our solar system, it's it's basically the Earth, which is the third planet out, that is in the Goldilocks zone. But our sun is a much brighter star than the sun in this little solar system, which is actually something called an M-dwarf star. And M-dwarfs are cool stars. It's much easier to find a planet around an M-dwarf star than it is around a normal star, particularly if you use that Doppler wobble technique, where you're looking for the wobble the planet induces on the star, because a lighter star, a less massive star, will wobble more. So people have focused quite a lot on these, what are called M-dwarfs, these cool stars. The only problem with them is they're known to have very active surfaces with flares and, the kind of storms that we see on the surface of the sun, only much more intense. But this particular one, it has been suggested that it is less of a flare star than many of these dwarf stars, because it's an older one. It's kind of quietened down a bit in its old age and has relatively steady light output rather than something that comes and goes in big flashes. And so that, again, is something that may be conducive to the evolution of life. Who knows? As always with these things, we're hypothesizing with very little information. What we do know with certainty, though, is that these planets are there.
And is it true that this situation, these planets, because of the larger size of the rocky planet, the smaller size of the other ones, is maybe going to give scientists or astronomers a potential understanding of planet formation? Is that something they were hoping to gain from this?
Yes, that's right. So it's the other way around, that the rocky one is the smallest of the three.
Okay.
And it's on the innermost orbit. And when you think about it, that mimics the solar system. But what is odd is that in our solar system, we've got the 4 rocky planets and then the 4 gas giants. And the boundary between them is something called the snow line. It's where water turns into ice, basically. And that seems to have been very important in the formation of giant planets. Whereas with these planets, the TOI 270 system, the snow line is much further out than any of them. So the gas giants are actually within the snow line, which might be, it's an interesting situation for planetary scientists to try and explain how they got like that. Maybe they formed further out and then migrated inwards, because that's another possible mechanism for this kind of thing.
Well, there have been exoplanets discovered that are gas giants that are quite close to their parent star,
that's right.
Which when first discovered was quite a shock. So
the hot Jupiters,
so it turned our sort of thinking upside down, quite literally. So
yes,
it
happens all the time.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And time now for another look at some of the other stories making news in science this week with a Science Report. A new study has found that warm-tolerant species of plankton and fish are slowly replacing their cold-tolerant counterparts due to climate change. A report in the journal Nature used international surveys dating back to 1985 to measure regional changes in the temperature preferences of communities of plankton and fish around the world. They found regions with stable temperatures, such as the northeastern Pacific and the Gulf of Mexico, showed little change to species. But areas with warming seas, such as the North Atlantic, showed a strong shift to species with a preference for warmer waters. Meanwhile, a separate study has come up with similar results, finding that climate change is causing a tropicalization of coastal ocean areas that were previously temperate. The findings, reported in the Proceedings of the Royal Society B, show that coral reef herbivores are starting to move into temperate waters, munching away at canopy-forming seaweeds, which in turn threatens the habitats of those living there first. Additionally, by chewing up these habitat-forming seaweeds, the researchers say the poleward journeying fish are leaving clouds of detritus and excrement, feeding a different group of sea life and potentially disturbing the existing ecosystem. A new study has found that omega-3 fish oil supplements improve attention among children with attention deficit hyperactivity disorder, or ADHD, but only among those with low levels of omega-3 in their blood. The findings, reported in the journal Translational Psychiatry, are based on a study of 92 children with ADHD aged 6 to 18 who were given either high doses of the omega-3 fatty acid EPA or a placebo for 12 weeks. Scientists found that children with the lowest blood levels of EPA showed improvements in focused attention and vigilance after taking the omega-3 supplements. But they also found that these improvements weren't seen in kids with ADHD who had normal or high blood levels of EPA. In addition, for those children with high pre-existing levels of EPA, omega-3 supplements had a negative effect on impulsivity symptoms. Scientists studying 6 adults who each had half their brain hemispheres removed during childhood to reduce epileptic seizures have found that the remaining half of their brains formed unusually strong connections between different functional brain networks, which potentially helps the body to function as if the brain were intact. The findings, published in the journal Cell Reports, looked at networks of brain regions known to control things like vision, movement, emotion, and cognition. The authors also compared the data collected at the Caltech Brain Imaging Center against a database of about 1,500 typical brains from the Brain Genomics Superstruct project. They thought they might find weaker connections within particular networks in people with only one hemisphere, since many of these networks usually involve both hemispheres of the brain in people with typical brains. Instead, they found surprisingly normal global connectivity and stronger connections between different networks. A tiny species of deer called the silverback chevrotain, which has not been seen by scientists for 30 years, has been rediscovered in the wilds of Vietnam. Since 1990, there have been no scientifically validated sightings of the deer, and it was thought hunting may well have pushed this species to the brink of extinction. However, a report in the journal Nature, Ecology and Evolution says scientists used local knowledge to place more than 30 motion-activated camera traps at specific locations, capturing more than 200 confirmed sightings of the rare animal. Scientists are now urging local authorities to take immediate conservation actions to ensure the creature's survival. Scientists have developed a virtual skin, which not only adds a new dimension to virtual reality gaming, but also gives prosthetic wearers a sensation of touch. A report in the journal Nature claims the new electronic skin can mold itself to any curved surfaces just like normal skin and responds to physical sensations using vibrations. It's one step ahead of similar devices as it does so wirelessly and without a battery. Beyond gaming, the researchers have shown that this material can be used to convey touch through social media and allows someone wearing a prosthetic hand to feel some degree of sensation. Well, spotting fake news is difficult enough these days, but what about fake or junk science news? Well, studies show it's pretty much the same deal. Firstly, always consider the source. Investigate the site to make sure they're not always pushing out a particular angle or viewpoint, or that they're being funded by a company or government that's got a particular propaganda agenda. Good examples of ingrained bias include CCTV and Xinhua, which are both funded by the Chinese government and so push a pro-communist, pro-Beijing viewpoint. Sputnik, RT and TASS are all backed by Russia and so push a very strong pro-Moscow, often anti-American agenda. CNN and MSNBC have a history of showing more than just a dose of Trump derangement syndrome, while Fox News goes the other way, being far more pro-Trump and GOP. Across the pond, the BBC is often accused of pushing a pro-Arab viewpoint. So bad, in fact, that crews aboard Royal Naval vessels during the Gulf War demanded the captain switch the cable news service they were getting from the BBC to Sky News, because what the BBC were reporting simply wasn't matching what the crews were actually seeing around them in the war zone. Even Australia's ABC, which gets over $1 billion of taxpayer funds every year, leans very strongly to the woke left, with 80% of its journalists voting Green. Next, always check out any links or sources to make sure that they're real and actually support the claims being made in the story. The book Dark Emu by Bruce Pascoe is a great example of this. Pascoe makes many claims about Aboriginal cultural practices and the settlements they live in. However, when you check the sources he's quoted in the book, it's clear that in many instances he's either badly misquoted them, completely misinterpreted what they've written, or added his own beliefs to replace the historical facts. And this brings us to the people who are writing the story or reporting the news. Always check the journalist, author or reporter to make sure that they're creditable, that they're real, and again that their body of work doesn't suggest that they're pushing a specific agenda. Sky News Australia has a problem with some commentators denying climate change and then trying to justify their claims by consistently cherry-picking data or by using scientists to try and legitimise their claims, despite those people not being real experts in climatology or meteorology. In fact, one commentator on Sky regularly rolls out a geologist employed in the fossil fuel industry to try and scientifically justify his climate change denial. Tim Mendham from Australian Skeptics says there are clear signs to look out for when trying to sort out real science from junk science.
I don't know how many people actually go to the science journals themselves when they're hearing a particular claim. There's obviously most people would hear about scientific discoveries or whatever via the normal mainstream media, blogs, social media, etc. But when you're looking at the science journals where these learned papers are supposedly published and you have to assess them yourself, which can be very difficult, obviously there are various tricks. Basically, the hard one is to learn some science and to understand some basic principles of scientific argument, etc. The classic one is that the dose makes the poison. I think we've mentioned this before, actually.
Oh, yeah. Dr. Carl says it best. Everything is a drug. It all depends on the amount you take.
That's right. Yeah, if you take 10,000 litres of water, you're probably going to die. So, yeah, so nothing is harmless, but it depends on the dose.
So what we do here at SpaceTime is we always look at the source journal, where it's come from. And unless it is a source journal that we know and we trust, in other words, all their work is peer-reviewed, then we leave the story alone. There are lots of stories which we see being run elsewhere, but we won't touch simply because it's not peer-reviewed and it's not in a creditable journal.
That's what I mean. For the ordinary person, the public, that can be a difficult thing to work out if it's a decent journal. But this is something put out by the American Council on Science and Health. And 3 basic rules: learn some science, question the experts, and don't fool yourself. Don't let your own biases get in the way. And that's critical thinking, really, through and through.
Yeah, and if it sounds too good
it applies to most
it probably is.
Yeah, probably is. And it's basically lessons you can apply to a whole range of areas, not just learned journals.
5 questions to ask when you're reading news stories on medical research.
Be very, very careful. You do get some universities and people like that who are very keen to get their latest discovery out, even though they know there might be years and years or decades to go before anything is totally proved. A few questions that is put forward by scientists, etc., themselves is: has the research been peer-reviewed, as learned journals, etc.? Has it been assessed by other people as worthwhile covering? Was the study conducted on humans rather than rats or bugs or whatever? So, because things that work on other animals don't necessarily work on people. Are the findings likely to represent a causal relationship? In other words, if A happens, does that mean B is going to happen because of it, or just is it coincidental? One of my classic favourites was that a researcher showed that kids who drink muck up in school. Actually, probably the other way around. Yeah, I know. But it doesn't necessarily follow. And as they say, people who drink coffee might have heart disease problems, but as someone pointed out, people who drink coffee might also smoke, and that causes the heart disease. It's very hard to find out a very strong link in a causal. It causes something, causal relationship. The other one is what size is the effect, and this is the watch out for the percentage. Whenever people start quoting percentages to you rather than numbers, be very, very careful, because percentage can be misleading. As someone says, if something has a 0.1% risk, and they just reported the risk has doubled, that means it's 0.2. So it's the size of the issue, not the percentage, and that applies to political movements, you name it, all sorts of areas.
That's something our politicians could keep an eye on.
Absolutely. Quoting a percentage, you doubt. You instantly sort of should raise a flag and say, let's look at this elsewhere. The other thing is they look at is a finding corroborated by other studies. There are individual studies done all the time that might not be very good. And basically the whole thing about science is it works by other people corroborating or not corroborating or sort of coming back and checking it out, etc. And the more and more you do that where they agree that this is true, the more you can have a reliance on it. Classic case is climate change. The 97% of scientists who agree, I'm not going to use the word consensus, who agree that this is happening and this is why it's happening, is a clear indication that the science has built up different people over a period of time.
That's Tim Mindham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram. On Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.